using a DNP translator, and basically I've captured the three messages, one from the master to the slave, and an acknowledgement from the slave to the master that the message has been received, and then the response from the slave to the master with the message. So let's start with the message from the master to the slave. The message is basically three layers. So you can see there is the data link layer, which is the top part of the message, and a DNP message always starts with 0564. As you can see in here, 0564. So that's a starting of a DNP message. The next thing that you will see is that the length of the message. So we can see 14 in hex or 20 in decimal, and that's the length of this message. After that comes the control part of this message, which is it tells us that the direction of this message is from the master to the outstation or to the secondary device. Okay, and some of the bits which can basically tell us about the controlling version and the function code that is being requested. Then we have the destination address, which is 50, the source address, which is 100, so 6400. That's the destination address and the source address. So this is a 20 length message, and it's from the master to the slave, and it has a destination address of 50 with a source address of 100. And then comes the cyclic redundancy check for, or the CRC for the header part. So in this case, it's saying that cyclic redundancy check is valid. On the transport layer, its only responsibility is to assemble more than one frames or multi-frames into a single frame. So in here it's saying this is the first frame and this is the final frame. So no additional frames are added to the device. And there is a counter for the message. The most important piece is the application layer. So this is in reverse of the stack that we discussed earlier, where you have the data link, the transport, and then the application layer. In the application layer, again, we start with a control, which basically tells us that this is the first fragment and the final fragment of a message, and the sender is not expecting confirmation, which is the master in this case, and we're sending a read request function code 1. All right, the user data, we can look at the translated data. So the translated data says this is a class 1, 2, 3, and a class 0, object 60, variation 1. So we are doing an integrity check, which means there is no range. Send me all the objects, all the points that is available in the target device. The next thing we see is a data link layer message. It has no application layer or a transport layer part. And basically the message size is, of course, it starts 0564, and the message size is 5 bytes. And then we start with the control, which tells that this is from the master to the secondary station. Right, from the master to the secondary. This is from the secondary station to the master in the direction of the master. And the destination address is 100, the source address is 50 with a valid CRC. Okay, then after that, we receive the answer from the device. And if we look at the translated values, as you can see, it only says 0.0 is 0, 0.1 is 0, 0.2 is 0. Now it's only sending the status of the points, okay? and it's sending that the first point index number is 0, the second, the last index number is 2. One thing to note here, the naming of the points doesn't get transmitted with the message. So you have to make sure that the name or the tag name is the same name or is what your operator is expecting to see in the point display in both the master and the server device. Okay, so hopefully this gave you a good understanding of what goes on between the master and the device with an acknowledgement, which is constantly repeating in a substation based on a polling duration that you pre-configure in your substation.